In this week's Physics Practical, we were assigned the task of using a magnet or electromagnetic based system to demonstrate and measure magnetic damping or levitation. We decided for this week we would focus on magnetic damping. Firstly, we looked at the definition of magnetic damping and found that it's the absorption of energy from a system using magnets. It works by having a moving magnetic object being slowed by still magnets. The resulting attraction caused by the magnetic fields of the two bodies causes the moving object to slow. Next, we designed a system that implements magnetic damping and allowed us to measure its effect. The final design involved a clear plastic pipe parallel to a series of evenly spaced magnets. The top 24 centimeters of piping was not exposed to any magnets to allow magnetic objects dropped through the top to accelerate. When a magnet is dropped through the top of the pipe, it accelerates before being exposed to the magnetic damping caused by the series of magnets running along the pipe. The interaction between the magnets slows the falling magnet and in some case causes it to stop entirely. In our experiment, we changed the mass and strength of the falling magnet and measured the stopping distance. This was achieved by stacking magnets on top of each other, dropping them down the tube, and recording the results. Two different sizes of magnets were used due to a shortage in resources. This included small and medium-sized ones. Small magnets weighed 1.7 grams, while medium-sized magnets weighed 3 grams. We repeated the test for each mass 3 times to achieve consistency. Our results can be shown by the graph seen here. As evident in a graph, there is a linear trend between the distance travelled and the mass of the magnet. This is expected because as the mass of the magnet increases, the force weight increases, meaning that a greater force is required to stop it. An assumption that was made was that there was a linear relationship between the strength of the magnets and their mass. This meant that the medium-sized magnets had approximately double the strength of the small magnets. In conclusion, it was determined that there was a rough linear trend in magnetic damping where the mass of the object being dampened is proportional to the distance taken to stop it. If this experiment was repeated, we could try varying the strength of the dampening magnets to observe the effects.